Hey everyone, welcome to this video. In this tutorial, we will simulate the stiffness in Abaqus. So talking about the stiffness is a measure of how much a structure resists deformation under a load. So in this simple model, we are going to have a plate with the dimensions as follows, made of steel, and we're going to have a concentrated force of 500 Newton in the middle. Alright, so without waste of any time, we jump to Abaqus to run the simulation. We start our simulation with creating part. So click on create part. The part should be 3D, deformable, shell, extrusion. And this is approximate size, let's say 400 would be enough. From this tool, create lines, we create a line. As always, we just create the line, then we add the dimensions. So you can either press escape or the scroll button of the mouse. So the scroll button is way easier. From add dimensions, I would add a dimension of 200 for this guy and press enter. And we click the scroll button of the mouse another time and have the depth of 100 millimeters. So as the part is created, we are good to go to the next module, which is property. We click on this one. The material should be steel, and from mechanical, elasticity and elastic, we have the Young modulus of 210,000. That's megapascal, and 0.33 for Poisson's ratio. And we click OK. Now we click on create section. The section should be shell homogeneous. So here we have the material, the thickness of the shell should be 0.8, and the material is material 1 or steel, whatever you name it. And from here we assign the section to this part and we click OK, and it says the section is section 1, and the sheet might be middle surface, and we say OK. So we have our section assigned. As the material property done, so it's time to go to the assembly. Here from create instance, we can create our instance here, and I would like to click on independent mesh because it's way easier for our model to mesh. So the assembly is done. Next step is to go to the step, create step here, step 1, initial static general, and I would like to accept these values. We click OK again, and from here we are going to create the middle point to apply the load. So from here we can click on create partition, and as we are going to do that on the face, so click on face here and use the shortest path between 2 points. So I select these 2 points and click on the scroll button of the mouse, so the partition is created. I would like to do the same thing for these 2 parts. We click the scroll button of the mouse every time, so we have the point here. So the next thing to do is to go to the tools, and from set and create, we can say central force, and okay, I use this one and click done. So we have our point, and from here we click on history output manager. So double click on this one, which is already been created by default, and from the whole model select the set, and here we select the central force, and instead of every n increments, select evenly spaced time intervals and put this value as 5, and uncheck the energy. Instead you can write down U2 and CF2 and click OK. So we double click on this one and see CF2 and U2 are selected. U2 is the displacement in the y direction, and CF2 is the concentrated force in the same direction. So OK, and the step and history output is done. We don't need interaction, we go straight to the load. From here we create the load, concentrated force, and we can either select this one, or from here sets we can select the central force, and this one is 0, negative 500 Newton and 0. So you see the direction of the force is downward. And the last thing to do here is to create the boundary condition. So from here, boundary condition manager, I would like to create a incast. We dismiss this one, and by holding shift we can select these edges, and we click done, incast, and OK. Click on this one and move to left so that we have that boundary condition from the initial step and step 1. Now it's time to mesh our model. We can go for a simple mesh, so mesh part instance, and say yes, we have the mesh here, and it is done, and it's time to go and submit the job. From here, job, let's say stiffness, continue, OK. From job manager I submit the job. Let's monitor it. It should not take that much time. Yeah, there we go. The job is completed, and we can see the results. Here I click plot contour, and we have the stress, and we would like to see the U, which is a displacement, so we have the maximum displacement on edges. But what we are after right now is to calculate the stiffness. So from create XY data, click on ODB history output, and we see we have these two results selected in the history output. Okay, by holding shift you can select these two and plot them. As you see, their displacement and force are here, and here it is the time. So we would like to make it correct. From create XY data, click on operate on XY data and continue. We should find the combine. Here we have the combine. We select U2, double click on it, then double click on CF2 and plot expression. We have it here. So this is force versus displacement. And to calculate the stiffness, we have to click on XY data and temp 3. We right click on it and edit. We have these values. We can copy them, and in a Excel sheet we can calculate the stiffness. So here I would like to copy them, or let's copy them here. I have to copy and paste it. So here, let's say this one is U, or yeah, U is okay, and F, and this one is stiff. Stiffness, and the stiffness is basically force over displacement. So here we have force over displacement, and this one, because it's 0 over 0, it's not making any sense. So this is the stiffness, and these values should be a positive value, but as we see here, the stiffness is around 22.8 Newton over millimeter. And that's it. If you enjoyed the video, please give it a thumbs up, and if you want to see similar contents and stay tuned, please subscribe the channel.